This is homework number 8, and I'm working on problem 18. I love these problems, don't you? Okay, it's another word problem. I know you don't like them. I won't humor you anymore. We have a lot of information here. We have that U.S. exports for the year were $12 billion in 1950, $1,550 billion in 2009. If exports grew, okay, this is going to be an exponential growth function. What was the growth rate of K? Round to 4 decimal places. Alright, so in this problem, we're actually trying to figure out what K is. And in our equation form for exponential growth and decay, our function form, which you should have handy. Again, that should probably be on a note card to help you out. This time, we know the initial amount. We know the amount it grew to. We have the number E. That's actually a number. We have the time, the amount of time it grew. And the only thing we don't know is K. So this one's going to be a little bit trickier. So let's write down that function on our paper and start figuring out where can we fit everything in until we only have one unknown left. Okay? So let's see. What was the initial amount, dollar amount of exports? Looks like it was 12 billion. So that's going to go here for P. Initially we had 12 billion. And notice I'm just going to write 12, and we're going to need to remember that this is in billions. Now, we've got the number E. We don't know K. That's what we're going to be finding. But we know the amount of time. The amount of time is from 1950 to 2009. So that's 59 years, right? So we're going to have K times 59, or 59K if you will. I can write it the other way also. There's one more thing we know. We know the amount that the exports grew to. They grew to 1,550 billion. Alright? So how do we solve a problem like this when the answer we're looking for, the variable we're looking for, is buried on this side of the equation? Well, we have to get everything around K gone. We've got to get K alone. So before we can do that, we've got to get E alone. So I'm going to start with this 12 times e to this power. Remember, that's times there. I'm going to get rid of the 12 first by undoing the multiplication. I'm going to divide both sides of this equation by 12. Alright, 1550 divided by 12 I can do on my calculator. And I get about 129.16 repeating. Now I'm going to leave that in my calculator. Don't clear that because we might be able to bring it back and be more accurate later on. Alright, the 12s over here are gone. They make 1. And then we have e to the, I'm going to turn this around, right, 59k. And remember, that's an exponent. Keep it up high. Alright, back in a previous problem, we learned how to solve these, back in problem 9. When we want to undo raising e to a power, we take the ln of both sides. So if I take the ln of e to the 59 times k, and I take the ln of the other side, because that's the law, you've got to do the same thing to both sides. What happens on this side is these two things cancel each other out. They undo each other, and I just get 59k. On this side, I can actually take the ln of this number. This is actually a function I can do in my calculator. Now, if you really want to be accurate, I've already got this number in my calculator, and I can use it again, or you can just abbreviate. You can just round it. But I'm kind of a fanatic, so I'm going to go, oops, I need my ln. I can bring that number back by pressing what's called my answer key, ANS. It's above my negative sign on this calculator. So if I go second, and then that key, it'll put the answer I got when I did the what was it, 1550 divided by 12. Now you don't have to be that precise. If you want to just go ln of 129.17, round it to 17, you're going to get as close an answer as you need. Alright, I get 4.86, about 1, and yours might vary just a little bit from that, but it should be close to mine. I'm almost done. Remember, I'm trying to get k alone. And remember, it's multiplication between the 59 and the k. I'm going to undo it with division. divide both sides by 59, and I'm going to have my K value. Alright, so I have that last answer in my calculator still, so all I have to do is divide that by 59, the 4.861 divided by 59, and we should get about 0.08, what do we want to round this one to? The nearest 10 thousandths, it looks like. 0.082, and I have a 9 after my 3, so that's going to become a 4. We have just found the rate of change. And if somebody asked you, what rate of change did the exports or imports, what was this, exports grow? That's about 8%. It's about 8.24%, in case somebody wants you to change that from a growth rate to a percent.